Today we are wrapping up chapter 6 with 6.7, perform similarity transformations. We talked about transformations and I briefly gave you a little information about dilations earlier this year. Remember we had that other project that you got to take home where you made pictures. Okay, the dilations are actually, in my opinion, one of the easiest transformations to do. For our warm-ups, we've got some critical thinking kind of questions. Give the coordinates of a point twice as far from the origin along a ray from 0, 0. Now, if you really wanted to, you could draw yourself a little coordinate plane and try to plot this out and think about it. But if we have a point twice as far from the origin as this point, that's going to make this point what kind of special point? I'm not looking for numbers. I'm looking for a name. So imagine we have our 0, 0, this point, and this other point that we don't know. This point here is the midpoint. This is going to be a midpoint. So it's like they gave us a midpoint, and we're trying to find the other endpoint. The midpoint formula is to take your x's and do what with them? What? We end up dividing by 2, but what do we do with both the x's? Add the x's together, divide by 2. Add the y's together, divide by 2. That's how we find the midpoint. They gave us the midpoint, so we know that the 3 is going to be equal to... We don't know one of our x's. We do know one of the x's, though. Where did this point, or this line start? 0, 0. So if we solve this, what do we end up getting for x? 6, comma. We do the same thing with the y's. We know that the midpoint has a value of 5. We started at 0, 0, so the y coordinate is 10. Now, with that as an example, you should be able to do number 2 without having to write all that out. What would the coordinates be of a point twice as far away? -4, 0. Essentially, what did we do to 3 to make it 6? Times 2. Twice as far times 2. 5 to 10, we multiplied by 2 for twice as far away. So we can do the same thing here. We just take these times 2 times 2 to get a point twice as far away. Questions, bless you, concerns? Okay. Similar idea on the next one, but this time we are trying to find a point half as far from the origin. Now again, we could set this up as a midpoint situation. This time we'd be looking for the midpoint. But since we are again starting from 0, 0, what could you do to both 6 and -4? Divide by 2, which is the same as multiplying by 1/2. So half of 6 is 3, half of -4, bless you, is -2. Which means our answer for number 4 would be good, 0, -3.5 would be half as far from the origin. Questions, concerns about any of the warm-ups? Bless you. Ready to move on? Okay. on we go. A dilation is a transformation that stretches or shrinks a figure to create a similar figure. Stretches or shrinks. A figure is enlarged or reduced with respect to a fixed point called, bless you, the center of dilation. Bless you. The scale factor of a dilation. Let's fix that. Is the ratio of a side length of the image to the corresponding side length of the original figure. So this transformation was saved for this chapter because we are creating similar figures. All of the other transformations that we learned last semester created congruent figures. These figures will not be exactly the same, but they will have angles, corresponding angles congruent, corresponding sides proportional. Anybody still writing on this slide? Okay. We ready? No. Not ready. Close to being ready? Okay. Okay. Anybody else? On we go. You can describe a dilation with respect to the origin with the notation x comma y goes to kx comma ky, where k is the scale factor. So what's happening between k and x and k and y? What operation? Multiplication. We are multiplying the coordinates by the scale factor. If 0 is less than k is less than 1, let's think about what that means. What kind of numbers would be in between 0 and 1? Fractions and decimals, yes. Would 2.2 be in there? No. Okay, so these are fractions and decimals that are less than 1. Okay, if that's the case, the dilation is a reduction, meaning we're making our figure smaller. If k is greater than 1, the dilation is an enlargement, which of course means we are making the figure bigger. Questions, concerns, need more time with those blanks. Okay. Draw a dilation of quadrilateral ABCD with vertices A, B, C, and D. Use a scale factor of 1/2. Who remembers what we call our new points after we do a transformation? The primes. So before we start graphing, we could just list out our coordinates of A prime, B prime, C prime, D prime. Our scale factor is 1/2. So what are the coordinates of A prime? 1, 0. B prime. C prime. Careful. 4, 1. And D prime. 3, 2. Questions about how we came up with those new coordinates? Okay. So they did not ask us to graph the original figure. You can if you want to, you don't have to. We do need to graph the dilation. I am assuming that you guys know how to graph points by now. 1, 2, 4, 1, 3, 2. Okay, you should be labeling your points when you graph them. And we should be connecting the quadrilaterals together, the points together to make the quadrilateral. Questions, concerns? I went through the graphing part quickly because that's something you should already be able to do. Nothing? Okay, we ready to move on? A triangle has vertices A, B, and C. The image of triangle ABC after a dilation with a scale factor of 2 is triangle DEF. Sketch both triangles, verify that they are similar. Okay, this one's got a few steps of work to it. We could go ahead and graph the original triangle ABC. That shouldn't be too hard. So 2, -1, 4, 1, 2, 3, 4, -1, and 4, 2. We should label those A, B, and C. In order to graph triangle DEF, we need to know its coordinates. If you want to put your prime notation next to them, D is going to be which prime? If you had to get, A prime, B prime, C prime. So if you want to keep that off to the side just as a reminder of where these are coming from, they're having us rename them DEF instead of using primes. If our scale factor is 2, what are the coordinates of point D? If somebody said them, I could not hear. 4, -2. Very good. What about B prime or point E? 8, -2. And F? 8, 4. Okay, I am going to graph those ones. 4, -2. I'm going to switch colors just to try to make them stand out a little bit better. So there's my point D. 8, -2. 5, 6, 7, 8. Point E and 8, 4. 1, 2, 3, 4. Again, we should be connecting those points. Before we move on to the verifying part, do we have questions about how we got our triangles? Okay. Any thoughts about how we're going to verify that they are similar? Micah, what do you think? The scale factor? Oh, the ratios. Yes, I agree. Technically, we have two different ways we could do this. One way to do it, probably the easier way for some people, is going to be to use side similarity to verify it. That would mean I would need to know the lengths of all of the sides and compare them to each other, like Micah said, to make those ratios and see that they all come out to be a scale factor of 2. Technically, on this problem, you could use side angle side. You would have to show that angles B and E are right angles by showing that the lines are perpendicular. Okay, that kind of switches gears a little bit. You have to pull in your slope and do all of that. So I would recommend side. If you feel strongly about side angle side, you could do that. So let's just start finding our side lengths. Some of them are pretty easy, like AB has a length of 2. What about BC? 3. Okay, to find the length of AC is going to be a little more involved. What are we going to have to do? You could, because that is a right angle, use Pythagorean theorem, or we could use distance formula. Either way is fine with me. What do you guys want to do? Distance. Distance tends to be more familiar at this point. Eventually, Pythagorean theorem will hopefully be more familiar. Distance between A and C. So we have to take x minus x squared plus y minus y squared. So for my x minus x, I'm taking what minus what? Okay, we could do 4 minus 2 squared plus, then what would my y minus y have to look like? 2 plus 1 or 2 minus negative 1 squared. 4 minus 2 squared is 4. 2 plus 1 squared. 4 plus 9 is 13. The square root of 13 does not simplify. So we know the length of AC is root 13. Moving on to our other triangle, DE has a length of 4. EF has a length of 6. In order to find the length of DF, we again would have to use distance formula. What's my x minus x going to be for DF? 8 minus 4 squared plus y minus y. 4 plus 2 squared. 8 minus 4 squared. 4 plus 2 squared. When we add them together, square root of 52, that will simplify. It is 2 root 13. You could break this into 4 times 13, 2 and 2. So the length of DF is 2 root 13. Now, hopefully, just from doing this, you can see that your ratios are coming out the same, but I should still see you actually make your ratios. Meaning, I would compare 4 to what? 2 and reduce it to be 2 over 1. I would take the 6 and compare it to, and it would reduce to, and I would take 2 root 13 and compare it to root 13, and I would reduce it to, okay? So then we verified it using side similarity. Again, if you felt strongly about doing side angle sides so that you didn't have to do distance formula to find those hypotenuses, you could use your slopes and show that those would be right angles and use side angle side. But that would require a different type of work to be shown. Questions about any of the parts of that problem? We ready to move on? Anybody not ready to move on? Speak now. On we go. Example 3, you want to create a quadrilateral JKLM that is similar to quadrilateral PQRS. What are the coordinates of M? Okay, so let's just kind of talk about a plan here. What's one thing that we could figure out from what they've given us already that would help us? What do you mean by that? Okay, Micah, what do you think? That what? M is another point that we're trying to find. M would correspond to what point that's already up there from our original one? S. M's going to correspond to S. So M we know is going to be out here somewhere. If we are creating a similar quadrilateral, that means that corresponding sides should be not similar. I mean, yes, but more specific than that. Would they be what? No, not necessarily. This goes back to like definition of similar figures. Corresponding sides have to be congruent is not correct. Angles, corresponding angles are congruent. I'm going to say it's going to be really hard to measure these angles, especially without like a protractor. What has to be true about corresponding sides for similar figures? They have to be proportional. There's the magic word. Corresponding sides are proportional in similar figures. If you tell me corresponding sides are similar, or you tell me corresponding sides are congruent, that would not earn you any points whatsoever. Corresponding sides must be proportional. Do we have any sides that we could already compare that are supposed to be proportional to each other? JL is not a side of that quadrilateral. JK and KL are sides of one quadrilateral. Ari? So bless you. I keep hearing people say sides from the same figure. I need sides from. So we need to start this problem off by finding the scale factor of our new figure to our old figure. Which two sides are going to be easiest to compare? Okay, KL and QR. Can we all see why that's easier? Okay, they are on the grid line, so you can find their measures easily. If you really wanted to compare JK to PQ, you could do that, but you would have to use your distance formula to figure out those lengths. I'll make that a little smaller. So we are going to compare KL to QR. What is the length of KL? 5 and QR 2. So that is our scale factor. Scale factor. If you would rather write it as a decimal, you could. Earlier on in the problem, we said that point M that we're trying to find is going to correspond to what other point? S. So it would be helpful if we knew the coordinates of point S. Where is point S? Five, 6. So then if we're trying to find the coordinates of M, what are we going to do to the 5 and to the 6? Multiply by what? The scale factor. So multiply it by the scale factor both times. 5 times 2.5. 12.5. And 6 times 2.5 is 15. Okay, so that would be the coordinates of M. That is definitely a critical thinking type question. That kind of question is going to get at, do you understand all of your vocab terms, how these things are related, how to use a scale factor? Do we have questions about that one? Are we sure? Because it took us a little longer to think through that than I thought it would. Okay?